is you're flying the biggest, most expensive thing around the world when it's all going to be in space anyway. Like, it's all going to the same destination, whether you launch from Florida or the...
Okay, so I just wanted to make this little video. It's a little awkward, but whatever. Okay, just wanted to make this little video reacting to the Terran 1 first launch. Context behind this: this is like the first orbital class rocket that I ever got to actually work on, put my hands on. Um, so yeah, figured I would just record my reaction to it, regardless if it takes off or not. But yeah, we'll see. I'm watching Tim Dodd or Everyday Astronaut, his reaction or commentary on the stream, because I like what he has to say. But we should be seeing Terran 1 taking off pretty soon. So yeah. Anyway, cool.
There's literally dozens of companies trying to launch to orbit for the first time, right now, basically. And so it's hard. And it is, unfortunately, sink or swim. And I would hate to see them go because I think it's such a cool concept. Watching it fly is amazing. It does not look great, though. I have a hard time really honestly imagining where it's going to go from here. So my thoughts are with everyone at Virgin Orbit. I really, 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 really hope you guys can get back on your feet and prove everybody wrong. But right now, it's just not. It's not great. It's not great. All right, so let's get back to a couple more. From Tim Kittle, are you going back to Starbase? Of course. Yep, I will be there when it gets closer. When we get closer to launch, I will go down there. I've learned my lesson to mitigate my time there because so many times I'll go down there a little too early and then sit around for weeks and weeks and weeks. I'm just not as productive there. I generally like the area is fine. I have some good friends down there, of course, that I like to hang out with, but it's just a different use of time. It's so remote. I feel so isolated there, and I just don't get a lot of work done. And I'd rather stay here in my zone in Iowa and just get work done and enjoy time with friends and family. I just feel like I'm a lot more productive here. And so I will be going down there just when we get closer. When I feel like we're within like 3 days is when I'm going to go down there. Because if we're within about 3 days, it means we're probably within like 6 days. We know how scrubs happen and all that stuff. So I'm going to just try to minimize that. And of course, it's going to be scary because we are going to have a lot of people flying in for this one. Not only on our team, but just around the world. There's going to be so many people flying in. So I really am going to be trying to call that as late as possible. Don't want people going there, showing up, and then being like, oh, wait, actually, it's not flying for 3 more weeks. That happens so often, especially with Starship, just because it is so developmental and it's such a brand new vehicle. Thank you to Ariadeta, PRDH. Greatly appreciate it. Have I started training? No, there's not been any training beginning yet for Dear Moon. But again, we're kind of just waiting on Starship at this point. We got to see Starship fly. The timing on that and how the success and the outcome of Starship's first orbital launch will put into play a lot of things in motion. Ooh, awesome. Andy, I really, really hope that you catch this launch. Again, bright blue flame from Methalox would be really cool. Technically, it's actually liquid nitrogen, but Methalox nonetheless. Yeah. From the same person, Ariadita. Sorry if I'm Ariadita. I'm so sorry. I'm so sorry for that. Will they also prepare the 3D printer human capsule for their rockets, planning for docking to the ISS? Yeah, they I think have full plans to 3D print. The big thing they're dealing with, obviously they can prove out if they can build a rocket, they can build anything. And the idea would be they would land these 3D printers on Mars and begin habitation and begin building cities completely autonomously on the surface of Mars before humans even get there. That's the key. That is the key. Ben says that this is all because no one has ascertained the status of the pointy end and the flaming end. Can't tell from this shot. We're going to have to wait for a little bit later on. Girlfriend Emily and I are huge fans and watch all your videos. Keep up the awesome work. That's so cool. I appreciate a a couple watching my videos together. That means a lot. I don't think there's a ton of people out there that have a couple both interested deeply enough in the topics that we dive into to watch them together. So that means a lot. Thank you to both of you for saying hi. William Stewart became a member. Much appreciated. From Justin Stoddard. Thank you, Tim, for all the awesome videos. Excited to see you fly around the moon. Thank you so much. I really appreciate that, Justin. What is going on? Thank you guys so much. Jeez, I've not been keeping up with you guys here. Thank you. Everyone say thank you to Justin. I can't wait to go around the moon.
We are less than 16 minutes away.
They're excited. They sound good. I love that. This is a good question from the Forbidden Juice in our Discord channel. Ooh.
Go poll for launch. Please provide concurrence to proceed in the launch countdown with go, no go. VC. VC go. GC1. GC1
That's Clay
go.
Walker on the mic.
GC2.
He's right
GC2
there, my
go.
boss.
Ground. Ground go. AVI. AVI go. FTS. FTS go. RF. RF go. GNC. GNC go. Flight software. Flight software go. Thermal. Thermal go. Prop 1. Prop 1 go. Prop 2. Prop 2 go. Fluids 1. Fluids 1 go. Fluids 2. Fluids 2 go. Loads. Loads is go. Rock. Ranges go. OSM. RC. RC go. Vehicle. Vehicle is go. CE. CE is go. LC. LC is go. All parties have reported go for launch countdown. Once the clock
LC's
begins to
launch
roll,
conductor
anyone
John
can call for a
Wiswell.
hold at any time. A hold is called prior to T-minus 70 seconds. The T-clock will continue to roll until T-minus 70, at which point a hold will automatically be initiated. A hold is not possible after T-minus 70, and any hold call after that will result in a terminal count abort.
Oh,
Should a hold manual be necessary, the person calling for a hold or abort should state clearly on comms, hold, or abort, abort, abort. In the event that OSM requires a hold, OSM will initiate the hold command on the OSM GUI and notify LD and RC on primary net.
And you just heard our launch director complete the go, no-go polling with our mission control team. As you heard, all systems are currently healthy, so as of now, we're able to proceed with our scheduled launch time in just about 13 minutes.
Throughout today's live stream, you've been hearing callouts from Mission Control. Let's take a moment to introduce you to our Mission Control team. Clay Walker, who you just heard, Launch Director. John Wiswell, Launch Conductor. James Harris, Chief Engineer. Elijah Escobedo, Vehicle Controls. Brian Batters and Zoe Dickard on Ground Control. Bill Stack, Ground. And Joy Mosdell, Range Coordinator. These are a few notable members also from leadership are supporting today's launch here at Launch Control. And this includes our co-founder and CEO, Tim Ellis, our Chief Operating Officer who leads product execution, Zach Dunn, Vice President of Test and Launch, Don Katterbeck, and Director of Cape Operations, Pat Svatek. These are among the many others who are making today's launch happen. Let's go ahead and take a moment to pause and listen in for any other updates from Mission Control.
Cool.
For our new viewers, let's give them a little bit more info about the systems that we're seeing on the pad once again. So the rocket rolls out of the hangar horizontally and is then lifted vertically by the transporter erector. That's the black vertical truss structure that you see behind the rocket there. The 4 large towers surrounding the pad.
The stuff that I got to work on was this raceway right here. You can't really see it, but I got to install all of these covers, which is pretty cool. And then a lot of these engines down here, I also got to test. Had my like arms reach way inside of them and all that stuff. So yeah, it's pretty fun. I actually was here. I've like walked right around here, and another cool thing too is these rainbirds, these like little towers. I don't know how well you can see it, but there's these little towers. They shoot water out at launch, so the sound waves don't damage the stand or like hurt people nearby. You know, sound suppression. And I actually I wrote all of the code that automates these rainbirds. So I don't know if it's still being run. They could have overridden it, but you can see the rainbirds here. These like fill with water and like shoot out water when this launches. But I wrote all the code that controls those things, which is pretty cool. So that's why I'm extra invested.
View 3 different levels under the rocket. So the largest and lowest level is the pad deck, and directly above it is the launch table. So this is where the launch mount pins to the pad and creates that flame duct. The launch mount on top of it is one component of the transporter erector. So it transfers loads into the pad deck during hot fire tests and engine ramp up at launch. It also contains the release system or hold downs and the quick disconnect or QD carriages that provide propellant and other commodities to the vehicle when it's on the ground. I do once again want to give a big shout out to the ground crews out here for all of their hard work. They've helped us build and operate this launch infrastructure and supported vehicle integration and testing. And of course, they helped us prepare the vehicle again for this 3rd attempt. So thank you all so much for all of your incredible work.
Can I just point out, I love hearing the excitement in their voices. Since they reset the clock again, you can just tell, you can hear it in their voices that they're getting excited. It does feel like it's becoming a lot more imminent.
According to our latest weather balloon data, upper level winds are currently go. Yes. So the T clock is going to continue to roll.
Countdown sequence has started.
There you go. We are just 10 minutes away from this historic launch.
Like I said, you can hear it in their voices. They are getting excited. That's the stuff that I love. I love that human connection. I love feeling connected to these people and their work and the people involved in building these rockets and getting humanity deeper into space and learning more and more about our place amongst the stars and just making new discoveries and pushing humanity forward. Yeah, I just love that. That's actually like that's the whole reason.
Minus 9 minutes and 20 seconds. Now in the next few minutes until launch, you'll hear callouts from our engineers and mission control as we go through the final procedural steps before liftoff. We'll be pressing the tanks, priming the igniters, doing the final engine checkouts, retracting the strongback, and then getting that final go for launch. We're currently proceeding with the launch time of 11:25 Eastern. That is 23:25 Eastern. Let's continue to listen in.
I love it, guys. This makes me happy. You know, and this is the whole point of Everyday Astronaut. This is the whole reason why I started this, was just to help share my excitement for this stuff. And my excitement gets fueled by their excitement, by the engineers, the scientists working on these projects.
Just my luck that the stream cuts out right when it launches. That'd be so funny.
It all comes full circle. The more they get excited, the more they do cool things, and I get to learn more stuff and hopefully get you guys excited along with me too. So thank you for tuning in with me here tonight. I know for a lot of people, especially if you're in Europe, say hello if you're from Europe. You are staying up very late for this little tidbit of history. Hopefully tonight we will see the world's first successful orbital launch attempt of a methane rocket. As a matter of fact, they could also potentially be the first rocket. If they get to orbit on their first attempt, they would probably be, by most definitions, the first rocket to make it to orbit on their first attempt. They're now pressing with autonomous pressurization. I just heard that in the callouts.
Because all the
views, we are launching at night today, but in terms of
the clouds have stopped coming out, so they're not. Oh, they're venting this. Hold on.
At night, the systems operate the same. You are able to see those white clouds a little bit more clearly now. So that big white cloud you're seeing come out of the strongback is due to strongback chill operations. So we're chilling all of the ground equipment to try to get our locks as cold as possible for stage 2.
Yeah, so because all the fluid is cryogenic, it's, like negative 300 degrees Fahrenheit. Like as you fill up the tank, it's going to pressurize the tank, right? But if you hit a certain pressure, then no more, you're going to hit the vapor pressure of the fluid. And so you're not going to be able to boil off any more of your propellant, but there's still heat going into the tank, right? And so at that point, your propellant starts to heat up and it decreases your performance. So to continuously drop the temperature of your propellant, you have to let it actually evaporate and boil off to drop that temperature. So it's a delicate dance of, okay, we want our tanks to be up to pressure, but we also don't want them to be too hot. And so it's like you got to do everything. It's like a moving target that you have to hit. which is why you'll see this thing like shoot off a bunch of clouds.
Yeah, at T-minus 70 seconds, the vehicle will go into terminal count, and this is when the vehicle's internal flight computer takes control of the countdown. We'll then go into final flight termination checks and get FTS go from the launch conductor in coordination with the mission flight control officer and operations safety manager. At T-minus 6 seconds, we're going to see that blue fire and have ignition of those 9
Hot metal blue
beautiful
fire.
3D printed Aeon 1 engines. And then at
Heck
T0,
yeah.
we will have liftoff and Terran 1 will fly. Shortly after, at T+2 seconds, the strong back will throw back to assist in removing the umbilicals and clear the path for the vehicle to fly.
Oh
and then
boy.
at T+12
boy.
seconds, we'll begin our pitch over program.
Hope they don't
so
have to
we'll
hold
go
anymore because I have
downrange in
2
an
papers
easterly
due at
direction
midnight tonight,
over
and it
the
is
Atlantic Ocean.
10:19 p.m.
And then
So
at T+80 seconds is that very important milestone of MaxQ, where the structural loads on the vehicle are the highest.
At approximately T+160 seconds, we'll get to main engine cutoff, or MECO, where the stage 1 engines will shut off. This is followed shortly by stage separation, and the Aeon vacuum engine will ignite on the second stage. Second stage will burn for a little under 5 minutes. Then at approximately 463 seconds, we'll get to second engine cutoff, or SECO. We'll go ahead and tune back in to mission control.
I should make a quick little note here. Amazing. Thank you so much for the incredibly generous donations. I will try my hardest to get to all these questions after launch. So I do want to listen in here at the end, and we're going to really pay attention to what's going on. But, I mean, a quick shout out to Jack King, another $100 donation. Thank you so much, Jack. I will get back to you in a second. I mean, just thank you. Everyone say thank you to Jack along with me. I don't even know what to say. So thank you, sincerely. Let's listen in here.
Stage 2 igniters, flight target.
We're now priming those igniters with gaseous oxygen and gaseous hydrogen.
Shoo. Gaseous oxygen, the most
In just
scary
about
substance.
30 seconds, we're going to be looking for the transporter erector cradle to disengage.
Gotta text everyone.
There goes the claw.
Stage 2 is on internal power. EE cradle disengaged.
All right, now those cradle arms are going to slowly release stage 2 so the strong back can retract. You can see the arms opening up there.
Love hearing a rocket come to life like this. Gimbal check. There's
Stage 1 TVC checkouts running.
And now you'll be able to see the stage 1 engines gimbaling or tilting as you see while we're completing those final thrust vector control health checks.
I love that.
Stage 1 is on internal power.
Alright, internal power, here we go. Let's light this candle.
It's getting chilly down there. Isn't it unbelievable how cold the rocket in this whole area would be right now if you were close enough to be able to feel that? It would just be freezing. So much.
The strong back will be retracting shortly here.
Come
See
on!
the thing on the right, the tower on the right, will recline a little bit away from
Strong
the
back is
rocket.
retracting.
There you
There
go.
it
We're
goes.
retracting
See it
that
retracting right
black
there.
truss structure to prepare for
Stage 2 TVC checkouts.
umbilical separation now that both stages are on internal power. And now we're doing those final thrust vector control health checks on the upper stage.
There it goes.
I'm concerned about stage 2. Honestly.
Starting final review of launch commit criteria.
Wow, we are very closely approaching T-minus 1 minute. I just want to remind all of us here that what you're looking at on your screen is 85% 3D printed, and it is about to fly.
Yeah, not just fly. Go to orbit, baby. This thing is ready to go.
Next up, our range coordinator will ask the range for their final status.
Please be range green. Please, we need the range to be green.
Rock, report range status.
Range green.
Yes, range green. All right, 70 seconds is
That
the
was
big moment.
confirmation. The range is green for launch.
And they made it past T-70. Okay. It is into the final sequence here.
Stalling closing out.
Flight computer configured for launch.
Oh, come on, come on, come on, come on,
They're
come on.
doing it, guys.
Under 1 minute.
1 minute.
Come on, Relativity, you can do this.
My hands are literally sweaty.
LD, are you go for launch? LD, go for launch.
There's that final go for launch. We are just over 30 seconds away
Last
until the
time
maiden
it
launch of this
canceled
vehicle.
at 5 seconds.
Good luck, Terran 1, and have fun.
Yo, they have
Here
the...
we go.
Oh, come on, come on, come on, come on. Yeah, last time it aborted at 5 seconds. Or 0.5 seconds. Oh, come on, come on. Oh, oh no, okay. We're good, we're
10,
good.
9, 8, 7, 6, 5, 4, 1.
It's going, it's going, it's going, it's moving. It's moving.
Terran 1 has cleared the tower.
This is it, baby.
Switch over maneuver starting.
Candle's been lit. Yo, it looks so good! Come on.
Look at that blue fire!
Yo, come on.
Yes! Wow.
It's doing it. It's clear pad, it's clear pad.
Cruising!
Yo, it looks so cool!
Look at that shot. Rock
Yo.
diamonds.
If you can hear me over the cheering, the vehicle is now headed downrange in an easterly direction over the Atlantic Ocean. Our next ascent milestone is MaxQ, around 80 seconds.
That's the point where we're going to really test out that 3D printed
This is
sky.
it,
One
this is it.
supersonic. Get
This is
telemetry
it.
switch over at the ground station.
Oh, come on. Come on. MaxQ, MaxQ, MaxQ.
Here's MaxQ.
MaxQ.
It did it. Let's go.
We are on our way to making a new history. Terran came ready to play today. You just heard that call out indicating Terran 1 just made it through.
This is from the...
MaxQ.
That's on board.
We just completed a major step in proving to the world that 3D printed rockets are structurally viable.
Yo, it's jellyfishing
Amazing.
too.
Absolutely amazing. Look at that. I love that blue flame. Methane is going to be
Hot
so
metal
fun.
blue
so many
fire.
rockets. Methane is so in right now. It's so hot
Up
right
next,
now.
we'll be looking for a call out that stage 1 performance is nominal.
It's cruising.
Dude, it's schmoving. It's schmoving.
About a fifth of the way through orbital velocity.
Oh, they've done everything that they need to do.
Coming up on a fourth of the way. The first stage does a lot of the heavy lifting, but it's the upper stage that actually does the majority of the velocity change.
Oh, no way, dude. Yo! That's so cool.
Remember, their video feeds here might break up a little bit. There's Miko. They're going through stage separation right now. And hopefully, second stage ignition. There
Yo!
it is.
Yes! No way!
As you can see, we were waiting for Miko and upper stage ignition. This means that we had a main engine cutoff for stage 1, and directly following that, we had second stage ignition, which you can see the Aeon
velocity's
vacuum
going
engine
down.
in that beautiful view in the night sky. Reminder,
cut
there is no fairing for this maiden launch as we don't
hey.
have a customer payload, but we
Amazing.
do instead have a memento of the first ever
Second engine
circular test
failure.
print.
It's done. Did not reach orbit, but huge milestone. Getting through stage separation and second engine ignition, massive. That's huge. I'm not sure what happened. The gimbal's still trying to counteract it, but it is still coasting upwards, but it definitely appears
We are currently standing by for an update on what's happening with the Stage 2 engine.
Yep. This is okay, though. They were so excited to get through maximum aerodynamic pressure. That was a huge milestone. Again, this is a demonstration mission. It's okay to fail on your first launch attempt. They are going to be celebrating tonight. This is a good thing. Yes, they didn't likely now make it to orbit, but getting through stage separation, proving out your stage separation, doing initial ignition of your second stage, huge milestones. So they are in, I mean, I don't even know how many companies have ever done that on their first launch attempt. That's huge. I don't think any that I know of even got through the first stage burn.
I'm literally sweating.
Whew, man. Yeah, they proved the most important part of their entire concept, which was getting through MaxQ. So huge props already. All the way through first stage. First stage has been validated.
Announcement on countdown. This is the LD. There has been a T plus anomaly with stage 2. LC, please begin anomaly procedure section 25. Copy.
Thank you, Relativity, for being so open with us about this. This is amazing to have this kind of coverage and this access to the information. We're watching and learning in real time. Just really is amazing for us spaceflight fans to be able to be tuned in like this. So thank you for watching along with us.
That's crazy.
As you heard from our launch director, we did have an anomaly with Stage 2 during flight. But maiden launches are always exciting, and today's flight was no exception. Although we didn't reach orbit, we significantly exceeded our key objectives for this first launch, and that objective was to gather data at MaxQ, one of the most demanding phases of flight, and achieve stage separation. Today's flight data will be invaluable to our team as we look to further improve our rockets, including Terran R.
Our team will now carefully analyze this data to determine what led to this outcome. So stay tuned to @Relativity Space on Twitter and relativityspace.com for additional updates in the days and weeks ahead.
I want to thank the entire Relativity team for all of their hard work in getting us to this point. No one's ever attempted to launch a 3D printed rocket into orbit, and while we didn't make it all the way today, we gathered enough data to show that flying 3D printed rockets is possible.
As Arwo mentioned, we will apply the lessons learned today in our future vehicle, Terran
Literally
R.
sweating.
What we are doing has never been done before, but it is undoubtedly a worthwhile endeavor that will transform the aerospace industry forever. And with that, we will conclude our coverage for tonight. I am Rachelle Aniceto. It has been an honor.
And I'm Arwa Tizani Kelly. Thank you, and see you next time.
Very nice.
Honestly, amazing. Absolutely amazing. All right, everybody. It's your turn in the chats to give a little applause for Relativity. That was so great. I'm really like that's a big deal. They made it through the biggest milestones. I'm trying to find out where did this go now. Yeah, I mean that is just absolutely massive. I can't say enough. I can't think off the top of my head another rocket company that has made it all the way through the entire first stage burn up to stage separation on the first launch attempt, besides Pegasus, which, you know, I don't know if we want to call that a private company, and that was a solid rocket booster, so a little easier. Pretty amazing. Absolutely amazing. Man, that was fun. I'm happy for that one. I am glad that one is in the books now. So huge congrats. So we're going to answer a few more questions, and I'm going to get out of here. I streamed for 6 hours earlier because I couldn't stop. And we've already been here for a couple hours already too. So let's tidy up here, answer a few more questions. Before we do that, don't forget, if you guys want, you can get our incredible 3D, not 3D printed actually. These are mold, injection mold. Falcon 9 model rockets. Again, these are entirely or mostly metal. I don't want to say entirely metal because they aren't entirely metal, but mostly metal. And you know, we have things like collapsible landing legs, and this thing can stand on its own. It's just an incredible. I don't think you're going to find a higher quality rocket model than this. This is 1/100 scale. It's the first of our 1/100 scale rockets. Again, you can hear it's made out of metal. It's heavy. It's like really heavy, which is part of the reason the shipping's so expensive to Europe. Sorry, Europe. Maybe the next run we'll do in like injection mold plastic or something. But this is beefy. You can clobber somebody on the head if they break into your house. This could be a home defense tool. But
So the stream didn't make it obviously clear enough. First stage launched, all engines ignited. It went up, hit MaxQ, maximum pressure. Thing didn't explode. Stage separation happened, and I think the engine started, but they said there was a T anomaly, thrust anomaly. Honestly, hard to tell. It could have aborted. I doubt that it would abort though, because I think they would rather have the engine eat itself up than to just turn off. It could have been a GG no light. They use a gas generator that needs to light to power up their turbo pumps to then push the propellant through the engine. They could have had a GG no light. That's like really common on AN engines. But regardless, they started it and then it fizzled out. But still hugely successful for the first launch, and I couldn't be more proud for having worked with the team. So hey, who knows? Maybe in the future I'll be working with them again. But for now, I'm going to Blue. So coolio. Anyway, I'm going to end this stream and freak out with my roommates about the launch. So good night and goodbye.